Okay, hi everyone. I am a grad student at the University of Michigan, and the very brief summary of my work is that I like looking for Trojan asteroids and studying these populations. And the primary way that I do this is through ground-based observations plus the shift and stack technique. So this is where you take your individual exposures, shift them at the rate of motion of the object, and then do the stack so that the object appears as a point source, like is shown in the red box in the image on the left, instead of a smeared blob on the lower left. And the main drawback of this method is that if you're looking to discover new objects, you don't know their speed ahead of time. So this generally means that you have to shift and stack over a pretty large grid of speeds, which can be computationally expensive. But the nice thing about Trojans is they're a great use case for this particular technique because their velocities are comparatively well constrained and should be nearly the rate of motion of their associated planet. So for example, Earth Trojans move at about 1 degree per day, just like the sun/Earth. And speaking of Earth Trojans, this is the population that I have focused most on most recently. It's an interesting population because even though we suspect that there should be a stable population of Earth Trojans, only one has been discovered so far. However, based off of upper limits from several dedicated surveys, so that's what I'm showing on the right, the yellow is actually results from OSIRIS-REx, the blue are results from my 2020 paper. Based off of these upper limits, there still could be hundreds of Earth Trojans, a few hundred meters in size, left to be discovered. And one last plug, what I'm working on currently is the purple line. These aren't current results, they're expected results, but the survey is better than our previous one. It utilizes shift and stack, and with the extra depth, we expect if we don't discover any Earth Trojans with that latest survey, we'll rule out basically anything bigger than 400 meters in size. And I'll leave it there.